Boom. Okay, 2020, what is it, March? We are going to do inverse relations today. And in order to do that, we're just going to do a quick review of some of the math you're going to need, some of the algebra you'll need before we dive into it. So, we're just going to solve some of these equations for x. Okay, so they're solved for y. We're going to resolve them for x because that's something we're going to be doing when we're doing inverses. So we're just going to add 4 to both sides. So we get y plus 4 equal 3x. And then we're going to divide both sides by 3 because the opposite of multiplication by 3 is division by 3. So there's your answer for that one. That equals x. That's not negative x. There. Good? Next one. What's our first step? Multiply by 2, right? So anytime you got a big fraction, it's dividing by 2. Multiply both sides by 2. Get rid of the fraction. Then we can add 5 to both sides. And then you have a 3x. So we're going to divide everything by 3. Okay, so everything divided by 3. And I'm going to be lazy. That's equal to 1. So now we have 2y plus 5 divided by 3. That equals x. I'm not going to rewrite it. I'm going to be lazy today. I got my glasses on. Good? All right, let's look at one that has a squared on the x. Okay, so you're going to want to isolate your squared variable first. So we'll add 5 to both sides to undo that. And then before we deal with the squared, we're going to divide everything by 3. So you're going to get y plus 5 divided by 3 equals x squared. Okay? And in this case, we're just going to do the square root. So you're going to write square root of everything. So y plus 5 over 3, that's going to equal x. If you want to be really fancy, you can put the plus or minus in front of the square root. Right, just as a reminder of the principal root and the non-principal root. That'd be good. Everyone's cool with that? You guys don't look impressed, so that's good. This one, well, now we have a squared binomial and the variable's buried in there. So just isolate that binomial. Okay, your mission is to isolate that binomial. So you're going to subtract 4 from both sides. Now you're left with that. Now this 2 is multiplying everything, so you can divide both sides by 2. Okay, so you get y minus 4 divided by 2 equals, 2 divided by 2 is 1, and you get x minus 3 squared. Now you would have seen stuff like this maybe when you were completing the square in grade 11, right? Like, you can just square root this, it's a binomial, so square root both sides, and you're going to get y minus 4 divided by 2 equals the binomial. We don't need brackets anymore, right? Don't forget you can always write the plus or minus there. It's generally a good idea in grade 12. So now you're just going to add 3 to both sides. So the best way to write it would be 3 plus or minus this square root, and that equals x. Done. So it'll become apparent why we did some of that practice when I show you what an inverse is, what it means. And nobody's got questions? Inverses, I don't know, like they're easy to understand, but they're sort of, I find like it's really easy to make like distraction mistakes. So I'll show you in a moment. So what we'll do is, first we'll just investigate a function and its inverse, and then we'll see what we notice about the graph. So here's the original function, f of x equals 2x plus 4. And I'm telling you that the inverse of it is g of x, and that's a half x minus 2. So I've actually went and gone and got a couple points from the original graph of 2x plus 4. Okay, and on the inverse graph, I'll just write it in over here, we're going to go 1/2 x minus 2. Let's go ahead and plot these points first. Okay, so 1, 6, and then 1, 2, 3, 4, 5, 6. And then we got 0, 4. And then we got negative 2, 0. So I might go use my line tool to go connect those dots after. I already put in the line y equal x, so that's for later. So if you're wondering what that is, that's the line y equal x. It has something to do with a function and its inverse. We'll see in a moment. So now let's go ahead and grab the point 1, and we'll pop it in here and see what we get. If you plug in 1 for x, and what's going on? Yeah. Or actually, my bad. The points we're going to do on the inverse, this might seem a little strange, but plug in the point 6 for x. Just bear me out for a second. If you plug in 6, what do you get? So yeah, I know. So let's just say if you plug in x equals 6, then what do you get for y? 1. Okay. It's strange, isn't it? Right, maybe you got 1, 6, and you got 6, 1. Try plugging in 4 for x.
2.
So you plug in 4, you get a half. 0 times 4 is 2, you get 0. So if you plug in 4 for x, you get 0 for y. So again, it's like those two things flipped. So what do you think you want to plug in for the last one? Plug in 0 for x, and you get -2. Okay, it's not obvious. It's not obvious at all. I'll do that one in blue. Should have done all the writing in blue, but I didn't. So now I have the point 6 for x. 1, 2, 3, 4, 5, 6, and 1 for y. And then I got the point 4 for x and 0 for y, so that's right on the x-axis. Then I got point 0 for x and -2 for y. So I'm going to go use my line tool. See if you notice anything. Now this program is really not meant for graphing at all, but you can try. I'm going to change the color to red. The line a little thinner maybe. Do another line here. So hopefully you have a ruler with you, I hope. Aha, of course. Crazy to zero.
Do we need to label like the x and y intercept?
On a graph like this where you have all the coordinates, like you got the tick marks, you don't need to label anything necessarily. So it is kind of tricky to see, but what do you guys notice about these two graphs? So the original and its inverse, and the line y equal x. Bearing in mind that it's not going to be perfect, but this is g of x, the inverse, and this is f of x, the original. We're going back to grade 9 now. Can anybody tell? What do you mean by symmetrical? Yeah? I think I know what you're saying. It's not quite right. I think you're on the right track.
He's right.
He's right. How do you say it then? These two lines, this line has been what? Has been reflected over the line y equal x. Okay? That's neat. Okay? So if you reflect over the line y equal x, what that means for you is if you're reflecting over that line, the way it works out is that the original xy point becomes yx. So that's what an inverse does. Okay, so an inverse takes the xy coordinates on one function and it makes them yx. So x and y trade places.
That's going to be so confusing.
Yes, it'll be very confusing. Because in terms of everything that you guys know, so you know all the things about transformations, and then you know, well, what does this mean? If I say take an xy point or take a function and do this. Yeah, this is called the reciprocal. The reciprocal. And what does it do to an xy point? It goes x 1 over y. So you guys have to worry about those graphs. You have to worry about inverse graphs, right, that do this. So this is inverse. So it's all very confusing. And you have to worry about absolute value functions too. Okay? So generally what happens is people get inverse, reciprocal mixed up for some reason. I don't know why. Because you switch x and y and here you go 1 over y. I'm not sure. I've never quite discovered it. So we'll look at it more officially. So here it is. So if you have a function f of x, the graph of x equal f of y is the image of the graph of y equal f of x after a reflection in the line y equal x. Okay? In other words, in maybe more plain English, I would maybe highlight this. A point xy on the original function y equal f of x corresponds to y comma x. All right? So if you want to write it in English, like you could just write, that's basically written in English to me. When the inverse is also a function, the notation f to the negative 1 of x is used to denote the inverse function. So this is the notation we use. All right, so in the last example, we had f of x was equal to 2x plus 4. The inverse, you write it like this. So that's how you write, hey, this is the inverse graph. You go f to the negative 1 of x, and then you state the equation. So that's what you'll see on the exam. And to summarize, I think this is really good. Given an equation y equal f of x, switch x and y to create an inverse, and then solve for y to isolate it and write the equation as f. There is a little negative 1 here, f to the negative 1 of x. So the reason we did those 4 exercises at the beginning where we were solving for x is when you're finding the inverse. So if I use this one, so you got y equals 2x plus 4. So to find f to the negative 1 of x, we switch x and y. So we solve x equal 2y plus 4 for y. Right, that's what we notice is x and y literally trade places. So that's how you solve for the inverse. You take the original function, you switch x and y, and you resolve that equation for y. So watch what happens. I'll bring this over here. I'll divide everything by 2. Okay, and then there's the equation. And then they cleaned it up a bit. So what they actually did is they did, okay, well, x divided by 2, and then 4 divided by 2. And that's the inverse function. So instead of writing y, we write f to the negative 1 of x. Right, and then if you want to, they wrote the fraction in front. So they wrote 1/2 x plus 2. Same thing. Any of those answers would do the trick for you. Okay? Number one thing to remember practically, right? Practically, if you have a graph, you take that and you do that. Okay? So a couple things to remember. How you do it algebraically, you switch x and y, resolve for y. How do you do it if you had a graph? Like if they're like, here's a graph, you know, sketch the inverse. You take x, y points and you make them yx. Okay? So like, I think it's easy to understand. A little bit tricky to do sometimes in practice. Yeah? Okay, so let's try a couple more. I don't know why I keep walking over here to change the slide. But, so it says, write the inverse of g of x equal 3x minus 6. Then use 2 points to see if your inverse produces inverse points where x and y are switched, and then graph them. Now, we're not too worried about this reflecting over the line y equal x. Sometimes they ask theory questions about it. Okay, so that's the only place it really comes up in the exam, is they might ask you a theory question. Like they might say like a graph and its inverse reflect over which line or something like that. But let's find the inverse. So find inverse. So we got g of x equals, what was it, 3x minus 6. Okay, so remember, this is like y. So you're looking at this. Is minus 6 or plus 6? Minus? Minus 6. Okay, thank you. Okay, so you got that. Switch x and y. And now resolve for y. So I'm going to add 6 to both sides. I'm going to divide everything by 3. So you could write it like that. I prefer to clean it up. So I'm going to go like x divided by 3, which is 1/3 x, and then 6 divided by 3, which is 2. And that equals g to the negative 1 of x. So make sure that you go back and you use whatever function they were using. If it was g, go g to the negative 1. Don't change that because you'll lose half a mark. So there's the inverse function. And let's graph them. So the easiest thing to do would be to make a quick table of values for g of x. And then do one for g to the negative 1 of x. Now, because you guys know what the transformation is, I wouldn't bother actually necessarily plugging points in on the inverse. I would just grab some easy points on this one. So like, what's the x-intercept? So when y equals 0, or g of x equals 0, I should say, looks like 2. You guys agree? Right? Like 0 equals 3x minus 6. I think we get 2. So we have the point 2, 0 on the graph. What's the y-intercept? So when x equals 0, you get, that's 0, so you get negative 6. That would be 2 good points to do. So we got 2, 0, and 0, negative 6. On the inverse graph, they simply trade places. Like that. Let's verify. If we plug in x equals 0, do we get 2? Whoops. Yeah. So I plug in x equals 0, I get 2. If I plug in negative 6, I would get negative 2 plus 2, 0. So clearly we have the right equation there. And then we can just go graph it. So let's see if I can do this. 2, 0, and 0, negative 6, 1, 2, 3, 4, 5, 6. So there's one graph. And then in a different color, I'll do the inverse. So the inverse is 0 for x, 2 for y. And then negative 6, 1, 2, 3, 4, 5, 6. I'm going to do my best. Living on the edge, no ruler. Living on the edge. By the way, bring a ruler to the exam. Now, if you're very visual, you might sort of see like, oh yeah, there's y equals x. You can kind of see that if you look at a 90-degree angle and a 90-degree angle, you can see like, yeah, those look like it's reflected over that line. We'll never really, we just talk about it in a theoretical sense, okay? Everyone cool? How do you guys feel about inverses? You guys feel that you basically know how to do them? Right? Like I said, if you know those couple facts, like an inverse means that you switch x and y. So xy on the original becomes y comma x. How do you find an inverse algebraically? You switch x and y and you resolve for y. What's the notation we use? We use a little -1 symbol. If you know those three things, oh, and let's throw in the graphs reflect over the line y equal x, then you're good for inverses. Basically. Okay? So I think, let's see if it's a good, we might stop it there and then finish the rest tomorrow and I'll splice the two videos together. Let's do this one last question. I think we have time. Yeah. So, they're giving you one of those blocky graphs. They say, here's y equal f of x. Sketch the graph of its inverse on the same grid. So let's go ahead and do that. So to do that, we're going to be taking these points that they've indicated, and we'll be reversing them. Let's try to do it without a table of values, shall we? So I will start here. 4, 0 would become 0, 4. Okay, I'll use a different. So 4, 0 would become 0, 4. This is the point 0 for x, 1 for y. That would become 1 for x, 0 for y. Negative 2, 4 would become 4, negative 2. So we go negative 2 for y, 4 for x. Do we agree? Okay. The point negative 5, 1 would become 1, negative 5. Now the question is, how do you connect the dots? Yeah, I think that generally works. Yeah, from left to right. So if you start here, so start with the furthest one on the left. I did go left to right. Oh, yeah, I didn't do that at all. So what would actually be the way?
From top to bottom.
Yes.
Really?
Yes. If you, I wanted to talk about this. When you do the inverse, if you know you're doing the inverse, it's from top to bottom, or from bottom to top. Yeah, if you're doing the inverse. Because everything's been reflected over the line y equal x. So if you're one of those really visual people, you'd be like, that actually makes sense. But if you're kind of like me, it's like, yeah, no, you're just going to need to remember it's from top to bottom or from top to bottom or bottom to top. Okay, so there's the inverse graph. So we could write y equals f to the negative 1 of x. There's that graph. Is the inverse a function? Okay. Question B reminds you that to be a function, 1x, I'm reminding you, 1x can only result in one y value. So every x has exactly one y. That's the definition of a function. Yeah, you got to pass the vertical line test. Okay, so this is a function if it passes the vertical line test. Remember, that means that you can draw a vertical line and you only hit the graph in one spot. So is there a place where this clearly does not pass that test? Yeah, right here at x equal 1, you got two values for x equal 1. You got 0 and negative 5. So is it a function? No. And you just say because it does not pass the vertical line test. Or you could say no, one x value has more than one y value. Now really quick, for domain and range, what would you be expecting? I wonder. So for the original f of x function, the domain and the range. So let's see, domain negative 5 to 4, and the range 0 to 4. Let's check out the new function. So the inverse function, domain, range, domain from 0 to 4. Range from negative 5 to 4. What's your conclusion here? So remember, domain, your x values, range are your y values. We literally switch x and y when we do the inverse. Domain and range literally switched. Does that make sense? Yeah. Okay, so conclusion, for domain and range of a graph and its inverse, they will literally switch. So the domain becomes the new range, and the old range becomes the new domain. And it makes sense, because we switched x and y. This is x, this is y. We switched them. Okay, so write that in English. I'll write that out. Yeah, looking at the results from C, what can you conclude? Oh, I did write. Is this in your notes? Did I?
Yeah.
I did. Okay, good. So the domain of a function will be the range of its inverse, and the range of a function will be the domain of its inverse. Excellent. We'll leave it there, and then we'll splice these together. Okay, this one here, we're going to quickly do this one. It looks like a good one. So they gave us a graph, and they just want us to sketch the inverse, and then is the inverse a function, and then state the domain and range. Okay, so I'll do it in black, the domain and range of the original graph, just so we'll do that. The original graph, domain and range, what do we got? Negative 4 to 3. And then we got from negative 1 to 4 for the range. Now, why don't we go ahead and make a prediction, because we know already. What should be the domain and range on g to the negative 1 of x? Without doing any work, knowing what we know, that domain and range switch, right? So we switch x and y. So the domain of the old function will be the range of the new one. So we'll make this bold prediction, and then we'll actually graph it. Okay, so the range of the old one is the domain of the inverse. So we'll actually go and graph it, and we'll see what happens. So I'm going to attempt to do this without writing it out. So I'm just going to take this, I'm going to start over here, and I'm going to just switch x and y. So we got negative 4, 4 is going to become positive 4, negative 4, right there. And then this point here, that's at negative 1, negative 1, negative 1? Yeah? That point's going to stay right where it is, right? Because when you switch them, you still have negative 1, negative 1. This point here is at 1, 3. So now we're going to do 3, 1. So that point goes there. And then this last point right here that is at 3, 2 is going to go 2, 3. Excellent. Do you guys remember how to connect the dots?
From up to down.
Yeah. Yeah, top to bottom or bottom to top when you're doing the inverse. So I'm going to go like that. And then kind of say like, okay, if I imagine line y equal x, this thing flipping over it, like, yeah. The reason this point doesn't move is because it's on the line y equal x. So any point that lands on that line won't reflect, right? Because you're reflecting over that line. It's on the line, so it actually just ends up pivoting. So that actually makes sense. Let's look at our prediction for domain and range. So the domain should be -1 to 4. Did we get it? Yeah. The range should have been -4 to 3. Did we get it? Excellent. Perfect. Now, is this one a function?
No.
No, why not? Because it doesn't pass. It doesn't pass the vertical line test. So when you draw it, I can find many places where I would draw a vertical line and hit the graph in more than one spot. Okay? Great. So that would be a pretty typical question on the exam. Like that's usually all they do. Sometimes they ask you to find an equation. They might ask you a domain and range question. They might ask you to sketch an inverse. Could be any one of those things. But chances are you'd only get one. There's like 3 or 4 things we can ask you. Usually you might get 1 or 2 tops. Okay? So, if you can do that, you should be fairly confident. Let's talk a little bit about writing inverse equations. We're going to be looking at quadratics right now. Okay, so notice that functions, right, I guess here's something to point out. Like, was our original g of x graph here a function?
Yeah.
Yeah, like it passes the vertical line test. Every x has exactly 1 y. So just because the original is a function doesn't mean the inverse is going to be a function. Okay? Like, and we just saw that here. Like, this wasn't a function, but the original one was. So I just mentioned that again. Notice that functions might have inverses that are not functions. So determine an equation of the inverse for this one. So let's go ahead and do that over here. So we switch x and y. So I'm going to write x equals y squared plus 3. Right? All I did is I literally just traded places there. And they're going to resolve it for y. So I'll subtract 3 from both sides. And then I'm going to do the square root. So I'm going to write plus or minus square root x minus 3. That equals the inverse. So I'm just going to write, I'm going to just call it f to the negative 1 of x. There. Well, there it is. There's the inverse. And then it says to sketch them. Okay, so we'll do that right now. So in black, I'll do this parabola, right? It's just y equal x squared shifted 3 units up, correct? Yeah? So we're just going to go 1, 2, 3. There's the vertex. And then the point 1, 1 would have went here. This other point, that's 1, 1, by the way. This is negative 1, 1, but it goes there. What's the point at x equal 2 for y equal x squared? 4? Right, so the point 2, 4 would now be at 7. 1, 2, 3, there. So that's a pretty accurate graph. Yeah? Everyone good? Yes or no? Yeah? Okay. Now, if we do the inverse, we can see the line y equal x. And it's a little tricky, but this thing should sort of flip on its side and be opening sideways.
Yeah.
Now, some of you will see that, like if you imagine y equal x. If you don't, that's okay because we have the equation. Now, there's 2 branches to it. So when we're graphing the inverse for a quadratic, we got to graph this function and this function. That's what the plus or minus means. So here's the plus one, right? And do we know how to draw that?
It's on the other side.
Yeah, where would that be? I guess I should do it in red, okay? I'll just make that red there, okay? So let's graph this one first. So it's y equal x squared, or y equal the square root of x, which should go through 0, 0, 1, 1, and 4, 2. And we shift it 3 units to the left or to the right? Just look at it. So it's shifting 3 units
Right.
to the right, right? Always the opposite. So the point at 0, 0 would go 0, 3. The point at 1, 1 would go over to 4, 1. And the point at 4, 2 would go over to 7, 2. So just 1, 2, 3. So that is the square root of x minus 3. Now, what would, same graph, what's the new transformation we're doing to it?
You're going to down.
Ah, well, is this affecting x or y?
Why?
Y. So this is a reflection over which axis? right? So you're multiplying all your y values by -1. So we're going to reflect over the x-axis. So what happens? This point stays right here because it's on the x-axis. This point goes down to -1 for y. This point goes down to -2. And there's the other half of that parabola. So that's a negative square root of x minus 3. Isn't that neat? So we did part A where we determined the equation. That, by the way, like most likely, that question shows up fairly frequently on the exam. They say, what's the inverse? What's the equation of the inverse? And then that's it. They don't even necessarily ask you to draw it. It's usually a 2-mark question. Sometimes they might say, here is an equation, or here is a function, sketch the inverse. Right? So if I gave you this, how would you sketch the inverse? I labeled those points, what would you do? What did we review before? You take those xy points and you would make them yx, and then you would plot them and you'd be done. Okay? Sometimes they might say, here's the domain and range of an inverse graph. What was the domain and range of the original function? Those are the kinds of questions you get. Every once in a while, they might ask you about, is the inverse a function? Yes or no? Okay? Now there's a couple ways they can do that. Is this a function? No. And then you would say, does not pass the vertical line test. You can't just write VLT. You have to write vertical line test. These are the notes, so I'm just gonna, okay? Because the marker is gonna be like, I don't know what VLT is, but a BLT sounds great, right? Like, you gotta write it in English, okay? But in the notes, we'll do that. All right, now, check it out. There's a way, without sketching the inverse, there's a way to tell if a quadratic if the inverse is going to be a function.
Is it the horizontal?
Yes, very good. Because quadratics will always flip on their side. If they don't pass a horizontal line test, the inverse won't be a function. Does that make sense?
Yeah.
Because look, this passes the vertical line test. This is a function. The inverse, if you look at it this way, well, there's lots of places where it does not pass the horizontal line test. So horizontal line test is not passed. Okay, I forgot the E. Therefore, the inverse, f to the -1 of x, is not a function. So they might give you a question like that. Everyone cool? And if you're like, I don't know, if it doesn't make sense to you, I suppose you'll just have to sort of remember for now. Well, for quadratic, if it doesn't pass the horizontal line test, it's not, the inverse is not a function. And that works for anything, actually, I think. I hope I'm not speaking out of line here, but pretty sure it works for any function. It should. Yeah, I think. Okay, here's the last question they ask you occasionally. It's the once in every 3 or 4 exam type question, in my opinion. So sometimes they'll ask you, let me just quickly check my notes because I'm adding it to this question to save us some time later. Easily tell, yeah. There it is. Right. Yeah. This one's sure what he's doing. Where's the freaking question? Maybe I'll just wait till we get there. I'm not seeing it in my notes all of a sudden. Who knows algebra? Oh, we can restrict the domain. Okay. I don't know. I don't know. I'm not seeing it right this second. You know what? Yes, there it is. Okay. So, just to make it easier for later. Sometimes they ask you, so I'm going to maybe go type it out. Sometimes they ask you to restrict the domain of the original function so that the inverse is a function. What do I mean? Exactly. So, if I were to get rid of the bottom half of that, is that a function?
Yes.
So the square root of x minus 3, that's a function. Yes, it is. It passes the vertical line test. If I got rid of the top half of that, is that a function?
Yeah.
Yes. So what they ask you to do is they say, take the original one, restrict the domain so that the inverse would be a function. So what we do is we basically cut the parabola in half. So if you got rid of this half of the parabola, if you got rid of it and you just did the inverse of this, you would get this piece. Okay? So sometimes they'll ask you restrict the domain so that the inverse is a function. Okay, now we always do it at the vertex because that's where the parabola is symmetrical, right? It's symmetrical around that axis of symmetry. So all you got to do, if you want to restrict it, so restrict the domain of, what was the function? It was y equal x squared plus 3 so that inverse is a function. You got two options. So you need to find the vertex, find, I guess, the x value of the vertex, and you either pick to the right or to the left of it. That's it. So you either say, okay, I'm going to go x greater than or equal to 0, that would be this half, or I go x less than 0. You just need to pick one. That's it.
Is there like a
Nope.
one?
Nope. You find the x value of the vertex, and then you pick to the right or to the left. That's it. Pick one. They'll both work. So for example, I might say use x greater than or equal to 0, or you could say x less than or equal to 0. Just pick right or left. I'll give you a hypothetical question right after this to make sure we understand. And so this question comes up every now and again. It doesn't happen on every exam. Like there's some questions in the course where like this is on every exam. This is one that's like every once in a while. Every like second, third, fourth exam, this question pops up. It's usually 1 or 2 marks. So okay, let me make up a question real fast. If you get it, you'll get this.
Oh, but then check the factor though.
So let's see. Restrict the domain of y equal. I'll give you 2. So this will be part A. So if you can get that, that's a good sign. And then part B will be okay, give you really quick, just write it out. Excellent. Sorry. And we're not even going to draw it, because you don't need to draw it to do this question. Should I do my waiting dance?
Yeah. No, can you like move over?
Oh, sorry. Was Kenny here? No. Was he here before?
You no, when I was holding my fish.
All right, let's go. So here we go. Restrict the domain. Okay, so all you need to do is find the x value of the vertex. That's all you need to do this question. What's the x? What is the vertex? You should be able to tell me the vertex.
0, 1. Wait, did you just put it into like completing this word?
This is 0, 1, yeah? Yeah? Okay, so the x value is 0. So to restrict, there's 2 possible answers. You could say, I restrict it like this, or I restrict it like that. So either one would be correct. You don't have to give both. I'm just giving you both because it's your notes. Okay, well that's good. how about this one? Restrict the domain of this one. So where is the vertex? And again, you don't need the entire thing, but you should be able to find it.
2 and 5.
Right. Where did it come from? Well, this is the x value of the vertex, and this is the y value of the vertex for this particular function. Okay, if there was an a value here, then it would be different. But they will never give you anything very complicated. And half the times they give you the graph. They'll be like, here's f of x. So you can like see the vertex, okay? So how would we restrict it? We would say that x would have to be greater than or equal to 2, or that's it. It's just that easy. To the right or to the left. To the right, to the left. Done. Okay? Good. I'm not a huge fan of that topic, but whatever. Okay, so in the notes now, I basically sort of covered the rest of the notes. This is another try it yourself. So it's the same exact question. Okay. Like I said before, if we use this symbol, we're saying the inverse is a function. Okay, so I may have used it incorrectly before, but we cannot use the word function if the inverse has an x value that produces more than one y value. We can easily tell if a function's inverse is also a function using the horizontal line test. Then maybe that's the thing you want to highlight. We talked about this. We did this on the last example, so this is the thing I was saying that saved us time. But we'll really quickly just do a sketch. So they're just saying, hey, look at y equals x squared, and its inverse. So its inverse would be what? The inverse would be, if you switch x and y and resolve for y,
Greater than 0 or less than.
what do you get?
Y equals
Plus or minus square root x. Right? And I'm just saying, well, just look at the square root of x, which is this one. Is that a function?
Yes.
Yeah? Okay. But if I graph the whole inverse, which would look like this, so this is negative square root x, right? It's just this half reflected over the x-axis. Is that a function?
No.
No. And then it goes on and says, how would you restrict this domain so that you would only basically get half of this graph? And the answer is, you would restrict the domain how? We just did one of these.
Greater or equal.
You would say x would be greater than or equal to, what's the x value of the vertex? 0. Or x less than or equal to 0. Greater than or equal to 0 would give you this piece. Less than or equal to 0 would give you the top piece. Done. So, would this inverse be a function? And how would I know?
No. It doesn't.
Does not pass horizontal line test, right? Right here it fails it. It's got a horizontal line, so it fails. What about this one?
No.
No. Does not pass horizontal line test. But remember, just because this isn't a function or is a function doesn't mean that the inverse might not be, right?
So wait.
Right? We saw lots of graphs that were functions whose inverses weren't. So you just got to check. Does it pass the horizontal line test? If it does, the inverse is a function. If it doesn't, it's not.
So it's not for all functions?
Do you have your hand up?
So if it's like not a function, but its inverse could be a function?
It could be, yeah. I don't know if I could think of an example right now, but it could happen. Sure, probably. Okay, good. And like guys, like I said, like on the exam, you might get 2 marks on an inverse question, right? Like we covered 5 or 6 things they could possibly ask us. You'll get like 1. You'll get 2 or 3 marks tops. Yeah. Okay? It could be anything. It could be drawing a graph. It could be finding an equation. It could be talking about domain and range. It could be a theory question. They might just ask you, like, how do you find the domain and range of an inverse if you have the domain and range of the original function? They might say explain. Yeah. How would you answer that question? You would say, since the inverse is switching x and y, you simply make the domain of the original the range of the inverse. You would just simply say it in English. Does that make sense? Okay, I think we covered the crap out of this. This is that whole spiel I was talking about. about restricting the domain, so I'm not going to go over it because we did a really good job, and this is really wordy, so if you want to read it on your own time, fine, but I think we did an amazing job. We could do this last question. Determine 2 ways to restrict the domain of this so that its inverse is a function. You want to do one more? Here's the graph of negative x squared plus 5. So where's that vertex right there? It's 0, 5. So how would you restrict it? You would either say x is greater than or equal to what? 0, or x is less than or equal to 0. Thank you. Thank you very much. That's it.
That's it?
Yeah, I've never seen them ask you to sketch it.
Oh, like, if we just sketch it, just take the book.
Well, how would you sketch it? Like, so let's practice. Let's pick a couple points. So what's this point? This is the point negative 2, 1. This is the point right here, 2, 1. So if I gave you 3 points, how would you sketch the inverse? It's a good thing that I taught the crap out of this. Well, what happens to the xy point on the inverse, on the original graph? What happens when you do the inverse? Yx. So I simply, we've done a million questions like this. Just switch the coordinates, sketch it.
Why
Done.
don't you just do the vertex and then just sketch a horizontal pattern?
Here, I'll sketch it down here. I can't see the points anymore, and I wrote over here. But okay, I'll get really messy. So here's 5, 0, and then I'm going to do the point 1 for x, 1 for x, negative 2 for y. So right there, and then there. Done. Okay? How do we feel? Good?
Good.
I think that's it.
There's one more.
To check. Yes, we should do this question. So sometimes they give you this question. They give you 2 equations and they say, are they inverses of each other? Right? So to check whether 2 equations are inverses, find the inverse of one and see if it matches the second equation. It's that easy. Yeah. So sometimes they'll be like, justify whether or not these 2 functions are inverses. So you pick one. All right. So which one shall we choose? I think it would be easier to do this one and see if we get that. Okay. So take y equals 7x minus 3 and find the inverse. So let's see. We'll switch x and y. So we're going to solve x equals 7y minus 3 for y. So we'll add 3 to both sides, and then we'll divide by 7. There's the inverse. Does it match that?
Yes.
Yes. So you would say yes, they are inverses. Perfect. Now, yeah, the second one is trickier. We can take a look at it. And then we'll be done. I hate like how much stuff we have to cover for like 2 marks on the exam. So I really like, I don't mind inverses, like they're cool, like we all sort of understand how they work, but it's like, man, like we just spent an hour so that you're gonna maybe get these 2 or 3 marks tops on the exam. But Danielle, you think it's worth it? You know what, I would have said exactly the same thing in high school. It would have been like those, I would have just been like, I could be at McDonald's right now or something. Okay. Let's do this other one. What did I even write there? The second example, yeah. This means, must have the same range. Well, look, at the end of the day, really, I'm still going to take this one. I would take this and I'd stay away from that one. And see if I can get that when I do the inverse. Ready? It doesn't work? I don't know, let's see. So I'm going to switch x and y. What's the number? I don't +1. Sure. Now you tell me when I go look at it. So solve it for y. Okay. So subtract 1 from both sides. Now, how do I get rid of the squared? Square root both sides. Do I need to have the plus or minus? Yes. So plus or minus equals, what do I have on the right hand side? Y minus 2?
Yeah.
Yeah? And then just add 2 to both sides, so you get 2 plus or minus this. Now this would be the entire inverse. Okay, but yeah, so I was talking about restricting because over here, they just chose one part of it, like the plus or minus is gone. So is that one of our equations where we have the positive square root and then plus 2? Would that be one of them?
Yeah.
Yes. So are they inverses of each other?
Yeah.
I mean, I guess yes. I'm not sure exactly the context of the question. Well, it says x less than or equal to 2. Right. So I guess they're kind of saying, is this the branch that corresponds to x less than or equal to 2? Oh, that sucks. Because then we got to go graph this bloody thing. So where's the vertex? 2, 1. So it would be like this. So there's 2, 1. X less than 2 would be this branch, which when we reflect over that line would be, what the heck would it look like? Yeah, that's right. Thank you. That would be the part that's gonna go like that. So does that equation correspond to this? No, it doesn't. It doesn't. You guys get it?
Sure.
Well, this is the graph of x minus 1 plus 2. This would be negative x minus 1 plus 2. So for x less than or equal to 2, that's this piece. Yeah. So they should have given us a negative here. So no, they don't. They are not inverses because of the domain restriction. I've never seen that question on the exam where they give you the domain restriction. Never. The only one I've ever seen on every exam, and I've looked at every exam that's out there, is this one.
Yeah,
That's the only one I've ever seen, okay? So if you didn't get 2, it's okay. We went a little bit deeper than we needed to, that's okay. I'll never do that again. Bye-bye.